Hello and welcome to Chapter 2. Our first section is about parallel lines and transversals. So we will be defining both of those throughout this section, as well as multiple other angle pairs that are formed. So let's first talk about what can happen when you have two lines. There are three things that can happen when you have two lines and you're looking at them at the same time. That's called a trichotomy, when three different things can happen. First of all, they can intersect. So when we solve systems, we're looking for where lines intersect. When we talk about perpendicular lines, those intersected in a very special way where it's 90 degrees, but they could intersect. The second thing is that they could be parallel. And the way that we show that as a abbreviation so we don't have to write the word parallel all the time is we use these two slanted parallel lines. Now, I always tell my students you can remember that parallel has two L's in the middle that look like the symbol for parallel lines. So what they are is they're coplanar, so they have to lie in the same plane, but they'll never intersect. Now, why is it important that they're coplanar? Because skew, which may be a new term for some of you, skew lines are non-coplanar lines that do not intersect. So parallel lines don't intersect and skew lines don't intersect. Parallel lines have to be on the same plane, skew lines don't. So really quickly, if I was to draw, let's say, our classroom to show you what I mean by skew lines or parallel lines, because this is actually kind of a common thing that you're going to have to find. This line is parallel to this line, it's parallel to this line, and it's parallel to this line. So let me number these 1, 2, 3, and 4. So 3 and 4, let's say, are on the same plane. It's the floor of our classroom. It's one edge and the other edge. 1 and 4, 1 is on the ceiling and 4 is on the floor. Now those are coplanar because I could connect them with a plane. That plane's not drawn in the picture, but a plane does exist that would connect those two. Skew lines would be something like, let me change my color here to maybe like a purple. Okay, so something like 4, that line, and this line right here. They are on different planes, and remember, these would go on forever and ever and ever. This one at the forefront and this back edge in the background. So even though here it looks like they intersected, you have to think about the depth in this picture. That back line, if I call it 5, is never going to intersect with 4. And in class tomorrow, we'll show you using pencils or something how that would look. So in this picture, we are asking which lines are parallel and which are skew. Notice the red arrowheads on the two lines. So notice these two arrowheads on these lines. What do you suppose they represent? In a picture, what they're going to represent is parallel lines. Okay, so anytime you see that, you know automatically, based on the markings on the picture, that those two lines, EG and KH, are parallel. So now let's answer that question. Which lines are parallel? EG. And again, line notation, you use 2 points on the line with arrows above, and then KH. Those two lines are parallel. Okay, and now which lines are skew is our second question. And I see that line FG, this line, intersects line EG. They're not on the same plane, but they do intersect. However, don't forget this dashed piece of a line shows that it's kind of behind the plane. It's trying to give this drawing depth that is hard to show on a flat screen. So it's trying to show that FJ intersects that plane. All right, so imagine in the room that there was like somebody stuck a sword through the room. FJ, that line, will never intersect KH. They're not parallel because they're not on the same plane, so they are skew. One is kind of ahead of the other one's behind and let's say perpendicular to the floor, and it's behind where line KH is drawn. Okay, so example 2, which lines are intersecting, which lines are skew, which lines are parallel, which planes are parallel, and which planes are intersecting. There are a lot of intersecting lines in this picture. So if I had to say some, I could say, for example, if I chose line HE. HE intersects with line HG, it intersects with line EF, HD, EA. And that's only if I chose line HE. Let's say I was like, well, what about line BC? BC intersects with this line, this back line, this line. So there's a lot of different answers. Skew, don't forget, is different planes and they don't intersect. So HD, for example, will never intersect with AB. It will never intersect with EF, and they're not coplanar. They're not on the same plane. So those are skew. If I chose, say, instead of HD, I chose line DC. DC will never intersect with FB. It will never intersect with EA. It will never intersect and not be parallel to, that's key also, HE and then GF. So there, again, lots and lots of different options here. Parallel, again, many options. If I chose HE, it's parallel to DA, it's parallel to GC, or GF, I mean, it's parallel to BC, and that's just one sample. Okay, planes that are parallel. In this picture, planes that are parallel would be like the top, the ceiling, if you will, if you think of this as a classroom, and the floor. Those will never intersect. The front and back, those planes, they will never intersect. They're parallel. The sides, the left side and the right side, these will never intersect. They're parallel planes. And don't forget, when you name a plane, you have to say plane and then 3 non-collinear points on it. So like my green right now that I have drawn here, I would say plane EHD. And again, I could use any combination of these 4 points because they're not collinear, and plane, and again, any 3 letters, F, C, B, let's just say. Okay, any of these 3 letters I would have to use to name that plane. And now for which planes are intersecting. Lots of different planes in this picture are also intersecting. Say I pick this front wall. The front wall is going to intersect with this right-sided wall, the left-sided wall, the top, or the floor. They all intersect. Okay, and so the only one it doesn't intersect, the front wall, is the one that it's parallel to, which is the back wall. And remember that when lines planes intersect, their intersection is a line. So if I wanted to know where does the front wall intersect with this side wall, it's going to be this line. That's the line that they have in common. But there are also lots and lots and lots of intersecting planes in this picture. Okay, so this is going to bring us to some new vocab terms that we're going to use throughout this chapter. The first one is a transversal. And a transversal is a line that intersects 2 coplanar lines at 2 different points. So in this picture, the red line, it's the transversal. The 2 lines that are black were just hanging out, and then the red line came and intersected them in 2 different points. So what happens here is that 8 different angles get formed. We have these 4 angles up top and these 4 angles at the bottom. I like to think of these as 2 different clusters of angles. That's what I'm always going to refer to them, the clusters. And so what's going to happen is we're going to learn some new pairs of angles, names that you're going to have to recognize. You're going to have to recognize these angles and be able to name them throughout this chapter. Okay, the first pair of angles is called corresponding. So they have to be in the same location of their cluster. As I call them, the clusters, they have to be in the same location within their clusters. So here, if we look at our 2 clusters again, where this little cow is, that cow is to the left of the transversal, but kind of above its line. So it's in the top left corner. So those are called corresponding angles. There's going to be 3 others that have that same location. So like angle 2 is on the top right, so is angle 6. Angle 3, where it's located, angle 7 has that same location, and 4 and 8. So those are corresponding angles. There's 4 of them in any type of 2 lines being intersected by a transversal. Okay, alternate interior angles. So when we have this, the angles that are kind of on the inside, they're called interior. Now, if my lines are like this, and this is my transversal, these are still on the interior. They're like on the insides. These are what we're going to call exterior in a moment. But alternate means opposite sides of the transversal. So there are alternate sides. So where the little stars in the top hat with the cane, where those angles are, those are alternate interior, and so are 4 and 5. So in this picture, there are 2 sets of alternate interior angles. Alternate exterior angles. They have to be on opposite sides. So remember, these are exterior angles. They have to be on alternate sides of the transversal, opposite sides of it, and exterior on the outside. So where the little unicorns are right now, those 2 angles are alternate exterior, and then we have 1 more pair of alternate exterior, 2 and 7, because they're on opposite sides of the transversal, or alternate sides, and then on the outside. The last pair of angles that we have here are consecutive interior angles, and they could be abbreviated to CIA. So they have to be on the inside, they're interior angles. And then consecutive means on the same side as of the transversal. So where these blue fish are, those 2 angles are consecutive interiors, and so are 4 and 6. So again, just to recap, when you have 2 lines that are cut by a transversal, what we get is 8 angles get formed. I like to call them 2 different clusters of angles. Within the clusters of angles, we have 4 pairs of corresponding angles. Corresponding angles occupy the same location within their cluster. There are 2 pairs of alternate interior angles, 2 pairs of alternate exterior angles, and 2 pairs of consecutive interior angles. All right, so here we have another drawing. We have 2 lines, and line T is the transversal. You don't have to be told which one is the transversal. The transversal is the one that does the intersecting twice. Notice the top line and the bottom line, and by top I mean this line here. Why is my stylus not working? And this line here. So the top line, the first star, the bottom star. Those lines don't intersect 2 lines. The top line only intersected 1, the red one. The bottom line only intersected 1 line, the red one. But the red line comes in and it intersects both. So I want you kids to go ahead and name a pair of corresponding angles, a pair of alternate interiors, a pair of alternate exterior, name a pair of consecutive interiors. Remember, you only have to name 1 pair. There are more than 1 pair for each of these. So I'm going to have a sample answer. Pause the video, you'll compare and see if your answer is one of mine. All right, here are all the possibilities for each of these. Remember, you are looking to have just one of them. And another thing is, if somebody asks you, name a pair of whatever, it has to be 2. You can't say angle M is corresponding. Corresponding with what? It doesn't make any sense. Pairs comes in 2s. When you buy a pair of socks, if you got 1, you'd be like, this is not a pair. If you got 3 socks, you'd think, this is not a pair. A pair literally means 2. Okay? So anytime you're looking for these angles don't make sense. You can't say angle U is an alternate interior. It's not. It's going to be alternate interior with another angle. It's going to be corresponding with another angle. It's going to be consecutive interiors with another angle. By itself, it's none of those things. Okay, this example is kicking it back to old school, to the things we've had. So the angle names that we've learned in chapter 1 still come into play here. If I wanted to name 2 pairs of vertical angles, there's a few in here. I have angle N and angle U, I have angle S and I have angle O. Down below, I have E and A, and then I have W and I have J. Supplements, 2 angles that add up to 180. So any linear pair in this picture is also going to be supplementary. So linear pairs, remember, come together and form a straight line. So I could say M and S, O and U, M and O, S and U. All of those are supplements. EW, WA, JA, EJ. Those are all supplements. Okay, so there's a lot of different options here as well. I didn't want to list them all, but if you don't understand that part of it, please make sure you ask. One last thing I wanted to mention, when we talked about parallel lines, and we said in the picture, you could be shown that it's parallel lines by these little arrows. You could write them that way on the lines. So the lines are always going to have arrows at the edges because they're lines. But to show that they're parallel, you would have these arrows on the lines. Another way you could show it is there could be a double pair, because sometimes you're going to have 2 different sets of parallel lines. So a single to a single means those are parallel, and then a double to a double means they're parallel. So for example, parallelogram, spoiler alert for 2nd semester, it would be drawn like this. So this shows that this side's parallel to this one side and the top is parallel to the bottom. That's the difference between a single arrow and a double arrow. Kind of like a single tick mark versus a double are showing that those are different links. A double arrow and a single arrow would show that those are not parallel to each other. All right, so in class, you're going to be working on 1.1, where you're going to be labeling and finding all these things. Thank you so much for watching. And I don't know if this Snapple fact is true, because I always thought it was, and I think this has been disproven. I don't know, Google it. Maybe we could talk about it in class next time we see each other. Have a great day. Thanks for watching. Bye.